Hello, hello, good morning. Let's see. Happy Sunday, everyone. I am super happy that man, it's another day off. Tomorrow is work again, but we don't have to think about that for at least 14, 15 hours. Today, or at least this morning, I get a bunch of time to work on this zombie simulator. So if we take a look at what we have so far, I believe we left it off with zombies are attracted to the humans. So when I create the zombie, we can see, and it's going towards the nearest human. And so now what I probably want to do is have it essentially eat the human, or attack the human. So when it overlaps with a human, then I want to stop the zombie, essentially stop the human, kill the human, and then pretty much like then the zombie can keep on going, right? So like the zombie gets zombie stops, so stop all the velocity, and then he can start like moving towards the next one. So that's what we're gonna do starting today. So now I already know that he's going towards the humans, so I need some way to like determine if we're overlapping with a human. So I do. It's one of the big questions about systems that like I don't know for certain. Well, it's gonna be written by a bunch of different ones. Like as time goes on, we're gonna get more and more zombies. They're gonna have to do more and more of these checks. I can't imagine it's not gonna become really expensive. So I'm thinking that I'm gonna want to in this system where we're in a zombie attraction. Well, we're getting all the other human locations. I guess I don't think it's that much work. I don't think it's worth trying to do this system like two things. Let's try the naive approach and just two system, like another system. This is gonna be the eat human, like attack human system. I guess we'll call this like the attack system. Okay, and then we should be able to head back over to the main library and then implement this. Oh, and the world. I forgot about the world. Okay, so I mean this should still work and run. Now what happens in attack? We need to get basically it's gonna be another one of these for all the zombies and for all the humans. The zombie is going to hit the okay, so we need to get like the distance between the zombie and the human. Lumacode, hello. How are you doing today? And also happy Sunday. Yeah, so we're gonna do another for all zombies for all humans. I'm doing good so far. It is just the beginning of my Sunday, but halfway through my weekend. Always wish it was longer, but it's all good. All right, so let's query for all of the zombies. So we're gonna need our location. And I guess just the fact that, well, we're gonna need your location and then we're gonna want to halt you. So we're gonna want the velocity as well. With component zombie, yeah, that could be good too. So we know you're a zombie. So with not again though. Then we want our velocity. And then I think we run it. Okay. And that then gives us this, okay? All right, so that gives us the vector of vectors. I'm gonna need all the other humans too. Now, if I were to just start looping through these, okay, we could do for zombie index, probably then just the zombie location. Oh, it's gonna be the wrapped zombie location. We're gonna do zombie query.iter, or we're missing enumerate. Okay. So that gives us, okay, this is wrap zombie locations. So we're now going to get the borrow. So that borrowed, zombie location is equal to, okay, so this is going to be the wrapped zombie locations. I guess I want to, like, we're not just doing the first one, we're doing 0. So that is there. So wrapped zombie location. Then we're gonna borrow you. Okay, so that gives us that ref9 any. We're gonna borrow the velocity. So that's the wrapped zombie location. No, not exactly. Okay, so this is gonna be the zombies query of position 3, 0, 0, 1, 2, of position 2. And then we have the index. And then we borrow it. Yes. Okay, so we get those. Now that I have the location, okay, we need to downcast these too. So, zombie location is going to be equal to the borrowed zombie location. We're going to downcast ref. We need to turn you into the appropriate thing, so you're a location. And then we're going to unwrap you. Now, borrowed zombie velocity, since we're going to be halting it, you actually need to be mutable. So you need to be borrow mute. That gives us a ref mute here, and then we're going to do the same thing. So that zombie velocity is a downcast mute instead of downcast ref. It's going to be the borrowed velocity. We're going to downcast mute. And you are going to be the velocity. Okay, so now I have mutable access to the velocity, the zombie's velocity, and just read-only access to the location. Okay, that's great, but I also need to get all of the humans. So let's go ahead and query them. So let zombies, actually this is gonna be the humans query. Okay. I need their location, yes. What else do I need? I don't think I need their velocity. Well, actually, I probably do, right? Because I'm gonna stop the human. When they get attacked, they have to stop also. And they're gonna get they're probably gonna get another component added to them. Or like dying essentially. Maybe we'll have like a live state that they're in, and yeah. But regardless, we will have the velocity, and then we have to make sure they're human. So with component human, and then we can just do this run. Okay, so now we have our humans query, which means now it's time for us to loop through, for every zombie, we're gonna loop through every human. Okay, so then for human index, the wrapped human location, in humans, query 0, we iterate and enumerate. Yeah, that looks about right. Oh, except there's one key here, is I think we're gonna have to clone this. Let's find out. So far not, but if we need to, we're gonna clone the entire humans query because, well, that's, you know, we have RC ref cells, so it allows us to do that. All right, so we have this. Now let's do this entire thing for our humans. So we have the borrowed human location, the wrapped human location dot borrow. That looks about right. Borrowed human velocity. We're gonna do the exact same thing, except 0, 1, 0, 1. That's the only difference. Okay, so you're a 1. And then we're gonna have this human index, borrow mute. Okay, yep, that's correct. And then we're gonna extract it out. So human location, borrowed human, downcast ref, that looks correct. And then downcast mute to velocity, yes. Okay, so we have we're looping through all the zombie locations, and for every zombie, we're looping through all of the humans' locations, and we have their velocities. So now we need to see what the distance is, which means we need to get the size. And I think the size is a resource, right? Yeah, add resource, entity size. So up here, let's also grab that entity size equals world dot get resource, and then you're gonna be getting the resource as a entity size. Okay. So what I want to do out of here is I want to grab get the difference between, okay, so get the distance between the location and the velocity. Okay. So if we're gonna do zombie location dot distance to human location that's close, and do distance. The other is gonna have to be a double D. No, this entire thing. Human location. And if you're less than the entity size dot zombie human, no. Okay, so if you're less than the entity size, which really means dereferenced entity size, probably double dereferenced. Let's just debug eating human. So we should see that eating human every time a human. Oh nope, never mind. Component for entity not found. Right, because zombies don't exist yet. We can't do this until the zombies exist. So we can't do that. We're gonna do equals. So we're gonna match you. Okay, fill your match arms. If you're okay, we're gonna get our query, and we're just gonna return that back. However, if we get this error, which is this report, then what we need to do is we need to return we need to do a full return. So return match on error dot downcast. Okay, so downcast this. I think it's downcast. We have to tell it we want to downcast into an error, which is component not found, I think. Oh, come on. Oh, right. It's just this error. It's like that. That's all we downcast it to, is that specific error. So these match arms. Okay, so then if we get a... Okay, and then I think we can do this component not found. We want to return an error of pretty much this, right? Otherwise, if you're literally anything else, oh, and here I want to return an okay, like that. That's what I want to do. So we're returning an okay. Otherwise, we're going to return error with the error inside. Let's see, the error got downcasted to this, so we no longer have access to you now. Oh, because we're downcasting this error. Can I clone you? No, I can't clone you. How did I do this in the other file? Probably not as what is it? Zombie attraction. Okay, so we mash the world query. Okay. Get the query and return that. Error. Match error. Downcast ref. Oh, I did the wrong one. Downcast ref. That's what I want to do. Then it's happy. Okay, so then you are. So expected enum, option errors, found enum, send a result. So you're okay. Do that. Okay, so expected enum option. Oh, is this a sum? Oh, it should be a sum. Yeah. So you're a sum now. Okay. There we go. Now this should work. So now when I create our zombie, Eating, okay, so eating human when it goes over the human. Okay, perfect. So we're getting some eating humans. All right, so that's working. So what do I do when I eat a human? First of all, I'm done with the humans, right? So we're gonna return. So we're gonna do an early return. We know that. The other thing is we want to kill our velocity. So that means our zombie velocity, we want to set that, we want to clear that. So we're gonna say zombie velocity dot clear. So that should reset that. And then we also want to clear the human velocity and set them to no longer be alive. And that's going to be the most interesting, right? Because we want to probably add a component to humans that they're dead now. So we want like a state on this. So let's so we want some kind of like state. And our state is going to be alive or dead, pretty much. Alive or dead. Probably like alive or dying, right? And if they're dying, how long it takes them to die. We can even just have that be something that, like, you know, all humans get like a certain amount of time to die. Let's create a component. This is going to be like life state, alive state. So in this case, do I want this to be like we were doing this might be an enum. And that might be okay. What if I do this as an enum? Will this work for me? So if I do a live state, so we have alive, and we have dying. Is this what we want to do? I feel like this is not what we want to do. I feel like to make things a lot easier for ourselves, what we really want to do is be able to just query for all alive humans. And then at this point in time, we want to add a new, we want to tell the world to add a new component to the humans. Like we want to remove a component from the humans and add a component to the humans. We want to remove the alive component and add a dying component. I think that's what we want to do. So we want, let's rename this. This is going to be just alive. And so this is going to be just a really simple marker struct here. And then when we create our humans in the main library, all you humans are going to get alive. Okay, that's great. Oh, you need to derive debug. And that means in attack, we want to query for with component alive. Okay, great. Nothing really changes from this. But at this point in time, I want to now tell the world we're killing a human. And what does that mean? We're going to be removing the component alive from a very specific human and adding a component dead to a specific human. I want to double check this first just to make sure that's working. Yeah, okay, zombie stops as soon as he eats a human. And then he has to start moving again, which is fine. Yeah, okay, so he's eaten like two or three humans now? All right, so I want to remove alive. I want to remove alive from the human. The other thing is, do humans get color? They do. They get this color white. So we are going to want to set the color to like a gray to indicate that they're like dying. So that actually is going to be here too. So we have, let's get the color. Okay, so if our distances to this are human color, we're gonna want at this point to extract that out, and we want to get it mutable so we can set it again. Which means we're gonna want, let's see, so let's do it above this. That mute human color equals, okay, so humans query of 3, so 0, 1, 2, 3, 4. It's gonna be 4. With the human index, and we're gonna borrow. It's gonna be borrowed human color. Then we're gonna get this out. So you borrowed human color, downcast mute, to color. Okay, yeah, that's right. So now we have that. And then we want to set a color on it to be some kind of like gray. Now we should actually be able to set this on the color itself, right? Like, I don't see a reason why I shouldn't be able to do something like this and say impl color, we're gonna have like a pub function, maybe set. We're gonna take a mutable reference to ourself. And we're going to set this color. Probably a new color. A new color, which is going to be this. Okay, GGZ graphics color. And yeah, we're gonna do that. Then we'll do, it's gonna be self.0 equals the color. And that's it. Okay, so doing that, we should be able to, okay, we set that. We're gonna need a resource for like the dead color. Or dying color, I suppose, is what it is. How do I want this to be? I think you're just going to be this right here. So you're going to be a GGEZ. So we can just do a graphics color. That. We can just impl a new on this so it just sets the way we want it to. So impl dying color. Oh, actually, I don't think we need to impl this. We probably will need to derive debug. Let's do our deref trick. Okay, so you become a graphics color, and then you are just a reference to self.0. We are also going to want to go into our config and update use. So we have a dying color. So pub color. This should be a graphics color. And that means in main, okay, we're gonna have dying color. I do not want to make this black. I want to make this like a grayish color. 0.6 is out, and 0.6 has like a pre-made, preset named colors. We don't have that. So right now we're using red and black. I'm thinking a very dark gray. Probably would be good for it, especially since all the humans are white. So let's try do a graphics color new. So to get a dark gray, I want to do a, so it's like it's 0 for black and then 1 for white. So let's do like 0.3 across the board. Okay, that should give us that. So then back into the main library. We're gonna now add this resource. So dying color, and this is gonna be the config.dying color. all of that so we can head back over to attack and extract this out so we can know what it is. All right, then down here, we want to set our human color to this dying color. So we have human color, this is mutable. So now we want to say human color set, this is going to be our dereferenced dying color. You wanted, I think what we want to do is just take a clone of this. Oh, that's too bad. I thought. Wait. So dying color is this dying color. If I clone you, that doesn't go in and clone the. Oh, that's too bad. Hold on. Have to do that. Yeah, I have to double dereference it. All right, so that's human color set. Okay, so now I want to check. Let's run this again. Are the humans that die going to now be like very not moving? So, oh, sorry, they turn gray to show that they're dead. They do. Okay, so I don't know. Can you see? Oh yeah, you can see that. So now, as the zombie goes around killing these humans, now the humans still move around, which is a problem. So we also want to stop the humans from moving. So at that point, we also need to reset the velocity of the humans. So we have the human velocity here, so we can just do the exact same thing that we do this. This is going to be human velocity clear. So this is great. And then we want to set the human state to not be moving anymore. To be like not alive. And that's going to cause it to not move. Mostly because we're going to be able to query for that in the move, like the human move system. So we have this alive. So let's open up I think it's like walk, randomly walks. This is human. And I also want to with component alive. Okay, so this shouldn't change anything. We're searching for if you're alive. I want to now check to see, I want to now reset it to be dead. Or I suppose in this case, dying. So let's create a marker component for dying. And in this case, I think dying is gonna hold an amount too, like how long it's dying. Although we can hold off on that for a second. So we'll call this dying. Derive debug. Pub struct dying. Yes, that's true. And then here we're probably going to have a value of how long we're going to be dying for. It actually doesn't matter. We can just start with this. And then we can like set this later. Okay, so right now you're just a marker trait. Okay, so then in attack, I want to remove one of the components and add another component. Now, is that true? Or I think it's really hard for me to do a search for like not dying, like a not component. So yeah, I think I want to like remove a component from our world, or from this entity, the human entity. So I think this is gonna be like the tough thing for today. Let's head over into our entities, and we're gonna figure this out. So looking back in here, we have, let's say, we want to remove, I don't know, location from this entity, and then like add on vision size, let's say. So I know that we have like entities by index, and the index is always correct because the map is there. So really we need to like check to see, we need to update the, okay, we're gonna need to update the map. We're gonna need to set this to a none to match what the map is. Is that even true? I don't know if that's true. We might just need to update the map. And then we don't care because the map is already just telling us what to even go for. We just need to update the map. And then we're going to add a component, which then updates the map as well. Well, updates the map and sets and actually adds the component. I think this shouldn't be as hard as I'm thinking, but I don't know, like I haven't done this one before, so it's gonna be interesting. All right, so update the map to remove this. That should be an or equals and equals. How does that work? It's the same in like JavaScript and Rust. It's the same operations. So if I have actually, let's just do this in the Rust. That way it is exactly the same. I'll come back to here. All right, so let's do. We have like our first number, so like our map item is going to be 0B 1 2 3 4 5 6 7 no 7 8. Let other equals 3 4 5 6 7 8. So I want to set, let's say, map to be a 0. Oh, and I guess this will be like our entity mask, right? So our entity mask is gonna be a 0. So we start with 0. And then we're going to do the and, I think. I think it's gonna be mask. I think it's or equals. So or equals map. So then this should be 1. So if we debug mask, then we get 1 because we just OR'd this in. So if it's a 0 or a 1, then just make it the 1. So our mask has this component in it. That's what we're saying right now. Now I want to remove that. Is that and equals? I think it's and equals now. So I added that in there, and then I want to don't take ownership. Then I want to do mask and equals map. We do another debug. Okay, that's not correct. It should have gone back down to 0. So that's not what I wanted. I don't think another or equals would work here. Yeah, that's or equals that. I think it's like the bitwise operators Rust. And we're the ones that set it. So we can see, okay, so we have and, or, but this is not going to work with it, I don't think. If I want to strip something out, let's see. I don't think it's XOR. I don't think it's not, because like if they're both in there, I guess I want to turn it into a not, don't I? Maybe I do want an XOR? Oh, this didn't take me to where I was expecting it to take me to. Okay, so bitwise is caret. So what if I try XOR? Oh, okay, that does remove it back to 0. Okay, so we get here, it's a 1. So let's imagine that this is I don't know, something back here. So this is gonna be 1, 2, 4. So we should see this as a 4 and then back to a 0 again. And if you had something in previously, so let's say that you had another one. So that'd be 2, 3, 4, 5, 6, 7, 8. So let's say you had a 1. So we start with a 5 because you have both a 1 and a 5, and then we're back down to 1. Okay, so the XOR is exactly what I want to do. So the XOR will remove it. Now, if I want to set to remove this component, I probably don't want to do that like right that second. What I'm gonna want to do is set that to be done at like the update as part of the update loop. Chantilly, hello, good morning. Okay, so what the plan is going to be, we want to remove an component. We're going to need the index of that component and the component type. That's really what we need, because at that point we can get the bit mask of it. And then we just update this. We don't actually have to update the components whatsoever. Maybe we can just do this all at once. Let me think about how would we want to do this. We'd we're not going to touch. No, we're going to touch the bit map. So we're going to get this out with a type ID. So we need the type ID, we need the index, and that's it. We don't touch you. So if we have a function here to do this, this is going to be remove component, and we're going to take in the type ID. I think that should work. So it removes oh, and the index. We need both. So mute self. We need the type ID. This type ID. We also need the index, which is this usize. Absolutely. Now, what are you gonna do? Are you gonna figure this out? So software components get. No, I don't want to get the components. We don't need to touch that. What we need to do is we need to get the bit mask. We're gonna do that XOR on it. Really, we want to get the bit map. So we need to get the bit map for it. So I guess that's going to be self dot bit mask of index. I don't want to set you to 0. We want to do the XOR. And that's going to be self.bitmap close self.bitmap.get. Our key is going to be the type ID. So in this case, you might as well just be a reference because you need to be a reference. And then we can unwrap you. And that's it. And that should just remove the component. Like it's as if the component doesn't exist for that user. Even if it's not set to a none, it is as if like we don't have to go in and actually do the work for it. Our map is telling us that nothing is there. And it's sort of like if you delete something from a disk drive, it doesn't actually delete it at that moment. It just marks the like table of contents to like, hey, there's nothing there. Don't go look for it. And that's why an undelete works, because it's not really deleted yet. Okay, so then if I remove component, we need type ID and index. So we're gonna head back into the main library of ECS, and we're gonna have a pub function remove component. So mute self, the component, import any. I think in this case, we're gonna need to do this entire T thing here. It's gonna be any plus static. Okay, mute self, and then the index. Which is a U size. And then I think that's gonna be it. So then it's not quite that. Self dot entities dot. We want to remove component. That's true. We want to get a reference to this type ID of T, that, and then the index is the index. Okay, so then in attack, we got to here. So now I want to, we do, okay, so we're gonna need mutable access to this world. So now can I do world dot remove component for this remove component? The component is gonna be alive for the human index. I think that this is wrong because I'm getting a new, I'm getting a completely different vector in here. Oh, okay, so this is a problem. Is like I don't actually know which index this is, because in the query that I'm getting here, we're skipping over the indexes. Oh, okay. So that's a problem. Now, if I wanted to do something like this, I would need to actually get I would actually need to like have the query return the index also, like the real index of what it is. So you need to be world Self world. Okay, so you technically work. I want to try running this because we should see the wrong humans stop moving. That's what I'm thinking. We're gonna see the wrong humans stop moving. But it should work. I'm looking to see like where's not moving humans. Because I'm seeing moving humans still. There's a human not moving. There's a human not moving. In the corners. Eventually it'll kill a human that's like in the middle somewhere. Oh no, it won't, because like they'll always be set moving, right? They'll have their last movement speed. So they just sort of like never stop moving. They just like keep on going. So that's a problem. But yeah, we're getting the wrong humans. That's our problem. So like they're always gonna end up in the corners, essentially. So we're gonna need to figure out what the true index is of each of these components, of each of these entities. Because right now, the index is not like the real index. Now we could add like maybe a vector of like the actual real index at the top, sort of like a table. That might not be too bad. What if we did that? So what if we go into query? So if we do query, it's gonna be entities, new query. In new query, we do a query new, but then we have this run query. Okay, so for type ID and query types, do all this stuff. Okay, then for index in components, then we're gonna push this in here. That should be fine. Okay, so we do the for index component and components. If query indexes contains, then we're going to push that in. Component as ref clone, and then we return you so that like it's almost like the first one. Got a double loop here, which is not. I think like I'm doing this wrong. I feel like the bitmap should allow me to do this with one loop. So I think we need to rewrite this. This is for the type IDs in the query type IDs iter. Okay, so for every type ID, then we're building out what we need. guess it doesn't really help that. Yeah, this doesn't help that we have like essentially a two-dimensional, like we have a grid down. So we need to figure out how to like grab the things we want and push them in. Well, here's the index though. Essentially, if we're pushing this, I then want to like throw this into like a vector, and that's going to be our index, our key. So let's imagine that we have let indexes. Okay, so empty vector, and then here. So I also want to just push in this indexes. So indexes dot push index. We have this result push queried components. I almost want to just put this at like the beginning or the end. Can I do like result dot there's like this JavaScript has like shift. What's the prepend maybe? No. Like result is this vector, so I kind of want like the first vector to be the indexes. Or we change you to be a tuple. Query result query result is this result with like this vector of that. What if I did like this? We have like a vec, a view size, and then that. Now here, now we can say indexes for that. Now, everything that I'm doing query-wise is wrong because it was expecting something different. Cool. So, query of like 1. Oh, this would be query 0. Query 1. Everything needs to be like updated by 1. Oh, wait. No, it doesn't. Hold on. This is query dot 1. Query dot 1. Query dot 1 to grab into the tuple. Yeah, there you go. So pretty much anywhere we have this like underscore query here with an open, oh, not that. Oh, really? You're not, there's not multiple selections there? Huh, okay. So dot one. Oh, don't want that. Want that. Oh, it's just those two. Okay. How strange, it's not able to catch these as different things when they're totally the same characters. Feels like a VS Code bug to me. Okay, so there's no errors anymore, but I'm not convinced that this is correct, because I think this has got to be way more of these than I want. So let's go into attack. And let's print out, just after our query, what this is, which is the index. So let's just debug. This is going to be zombies query 3.0. When do you know if you've come to a conclusion? Haha, very funny. Also, it matches with the name, so perfect. Let's see. Where's our PowerShell? Let's run you. I mean, this is lots of them. Selective duplicate, hello. Yes, I'm doing I do a lot of weekend streaming. Okay, so this is not super helpful for me to like debug out. I think what I want to do is actually do like just get a length and find out like what is the length that's different than the zombies query.1 length. Needs more turbofish. Oh yeah, I mean we have to see tons of turbofish. Are we gonna see a 5-6 hour? Well, I'm gonna be streaming until around 12. So yeah, actually, I started an hour and a half ago. So yeah, we're right in the middle of it. Okay, so I want to see, are the lengths of these, if the index and like the components the same? And my guess is, oh, they are. Well, I've got, ooh, okay, hold on. If that's true and it works, and it just works, then down here we can remove component, and I don't want human index, I want out of the humans query this. So that's going to be the humans. Okay, so the humans query dot 0 of the human index. Will that work? Got an error in Rust library. So no, I don't have a real error. Okay, let's try this and see if we're killing the right human now. No, we're not. Somewhere is a human that's dead that's not that one. Oh, wait. We haven't actually, have we not done the work? Did we not do the work? Debug macro is really neat. Oh yeah, debug macro is like my new favorite trick. So when I'm doing this, am I actually doing the thing that I want to do? We're removing the component alive. Here. Which should cause it to not be, like something should now be set. Essentially I want to add a component dying. I know, dying color. So I set the dying color for what they should be, and that's correct. Now removing this component alive, I didn't do this right. I'm curious, like what is this? So debug humans query dot 0 of human index. I am not using the colored crate, no. But I'm using GGEZ, so it's just a GGEZ color. So like 70, 68, 48. Unless I'm because I think we're setting the wrong, like like we're killing its velocity. And then you keep on moving because like we kill your velocity and that's great and all that stuff, but then we add in other things. Okay, so I think you're dead. You're dead. There's probably more of you on top of you. You're dead. It just happens to be dead. It's not like the right one. So what I'm curious about is, did you get set correctly? Probably not. Or is that actually Now I did this, I did this based upon the zombies. Maybe that was incorrect. Did a debug there. Let's do a debug of like the difference between the sizes here. So let's do debug of, so this is gonna be the humans query dot zero dot length. And then I want humans query dot one dot length. I want to see if like this is correct. Very much not. We have a length of 5 for 1, 495 for 0. So 0 is supposed to be the index, like the number of indexes. 5. Oh, because it's 5 components. Okay, hold on. You need to do this right. And then like the first one, it's like the first location there. Look at this. Okay, so we have 5 times the number of them. So that's our problem. It is very weird. It's not optimal. I'm trying to get the true index for each of these, which is not. It's so what I want to get is when I get the query, I want to get the indexes. So we know that like this is gonna be index 0, 1, 2, 3, 4, right? But when I get a query, so if I query for everything that has both a location and a color, I'm gonna get an array of this and this. So it's gonna be a length of 2, which means that its own index will be like 0 and 1, but really I need to know that this is 0 and 3. If I ask for the ID, well, no, I want the index of it to be the ID essentially, because that works. It just works. I don't have to do anything like crazy. So my initial idea was have return two things in our query. Return the list of indexes and then the list of things in like a tuple. I should probably return an actual struct that has like indexes versus this. That'll make it nicer. Like have a query result struct. Our problem is that in entities here, I can't just push in the indexes here at this point. I guess I could, but only for the first run through. I suppose I could create a variable that's an option maybe, and we can set that here. And then at the end of this one, we push that in. That might work. So like, let's say I do let mute like the ID is going to be a none. And inside of here, if it contains the index, so then we're going to do if ID is none, then ID is equal to the sum index, and that, and then down here, we can do the indexes.push ID. Okay. Oh, and then I want to strip out all of the options. So I want to indexes equal indexes dot, can I map this? No, iter mute. I guess I can like into iter. Into iter, so I get access to it. They're gonna map it. I want to filter map. It's going to map it. It's going to be an index. I want to index.unwrap. So you're an option usize. Oh, but I want you. So I want you in the end to be a vec of usize. Oh wait, we need to shadow you. Let indexes. So we need to shadow you. That's what the problem is. Okay. Then it works. Okay. So when I shadow it, it works. So let's try this again. Now the length should be the same. And as soon as he ate a human, index out of bounds, the length is 5, but the index is 71. Oh no, they're not the same. Got the same problem. Ooh. Well, that's okay. So that's the number of components that we queried for. That's our problem. The number of components that we queried for, because if we see in here, we queried for 1, 2, 3, 4, 5, and that's why the length is 5. So that's incorrect. In our entities, what I want to do is, I'm still thinking I need to rewrite this. I think what I'm going to do is I'm going to go refill my water. And maybe in doing that, taking like a quick, 5-minute break or something like that will help me realize what exactly I need to do. So I will be right back. I'm back. All right. Thank you, Lumicode. Okay, so one thought that I had was the index is really the index in the bit mask. Can I somehow use that? And like every time I push in another one of these, I push in like the index of the bit mask. Or bitmap. And so therefore it wouldn't really be like these. We'd have like, okay, so indexes and indexes for that. This is like down. So this is going down like that. But perhaps a bigger question would be like, can I get rid of this and like just not do this part at all? So let's say I have something like this. Here's our mask, which is technically separate, but it's the same length. And these are sums and these are nones inside of here. So if vision size doesn't exist, let's say, I want to get everything that has locations and colors in this case. So what does that mean? That means I can open up the map, and if I first create a sub, like an array of indexes to get here. So instead of nested for loops, I just do 2 loops next to each other. Would that work? How would the logic for that work? I want to do 4. We loop through the all we have at this point in time is we have the query. Okay, so the query is going to give us we have this like contains, so query indexes contains, and then this index, which is going down, and then the components. Selective duplicate. So this web app is called Freehand. It's Envision Freehand. It's actually really cool. I like it a lot. It is Envision Freehand. If you just go to Envision, you can create a free account, and they allow you to have like, I think currently an unlimited number of these freehands, and then up to like 20 people can join for free, although they have to have accounts. It used to be that anybody could come in and just sort of like do whatever they wanted to with a freehand, but now if I share this with you, you would need an account to like edit it. Right now I can just say like, hey, anybody with this link can view it. So for example, if you want to view this one on your own computer, that link will get you in, but you won't be able to touch this because I've set that so that you can't update it. And unfortunately you can't, like, I don't think even do comments or anything else. You have to log in for that, which makes sense. I think Envision has slowly started discovering that they made something pretty cool here. And yes, I can. Yeah, everybody else can see your cursors and everything else. It's actually really cool. I love it as like a teaching tool too, and like a pairing tool. Let's see. So we have our type. We have the list of types in here, right? We have, oops, sorry, hit the microphone. We have this query, and our query has the type IDs that we're querying for, and the indexes. What is the indexes? Okay, so with component is that. If has component index, okay, so then for so we create this list of indexes here. I think this index is what I want to get. This is the indexes. This is essentially the IDs. So can I like reverse this and then work with it? If I state that I want to loop through these indexes, I don't necessarily want to do the double loop thing. But if I have this, I've already done one of the for loops through it. I don't know if I can get away from the double loop thing though. However, I might be able to just return this, right? So we're returning this query result. What if this query result, okay, so query result, I'm gonna undo you again. Hold on. You're like this, but what if I want to return you as a tuple, and we're gonna do self.indexes and then return that. That means entities, you're the only thing that needs to be updated. We're not gonna do any of that. Oh, because like you're directly on the query. Yeah. So query builder, I would then want to say that you're going to be a tuple of a vec of usize and that. Use a partially moved value self. Can I clone you? Yes, I can. Cool. Everything else broke. Oh, hold on. Everything else did break. I need, okay, so this is query result is like this result. Ugh. I kind of want to like remove you from this. So then I want entities. You might be this query result. You are up here. You can do result like this. I want you to be an error result. Cool. Then in query builder, that should be fine. We removed the result from here, which means that you should be a result here. Like that. Okay, so you're happy there. Now these tests are unhappy. Not indexing the value of type. So do you not need to be... No, you still need to be question mark. Oh. Because new query returns a query. Oh. It's like .0. That's where I want to do it. No. Hold on. This gives me this. Oh, .1. .1. That's what I want. Okay. This is in the main list library, so I don't care about that. Okay, so you're working. Let's try this again. Still not killing the right one. However, notice that we're getting like 97, 97, 97. Okay, so everything here is looking right. For like what this is happening here. Okay, so then we have our random walk needs to be alive, right? So random walk, we're checking with alive. This seems to be working. So here we're doing, okay, so remove component alive from humans query .0 of this human index. So that should give us what we want to do. It's clearly not like deleting that, but let's make sure. Okay, so randomly walk is checking for alive. I'm actually curious, like how many of these are we getting? So if I do debug of query .1.length. Are we getting 100 or is it dropping down as people die? We're doing 4. Well, that's incorrect. I needed to do the first one in that. Create at 1 of 0. That's what it needs to do. Okay, so we start with 100. Zombie starts attacking. Now we're at 99. Okay. So we are successfully killing humans and like removing them from this. They're not getting this random walk, which is adding to the acceleration. So like choosing a random one, I guess. Okay, so if that's working correctly, what systems do I need? So add zombies, attack, contain, human repulsion. This only happens if you're alive. Let's see. Randomly walk only happens if you're alive. Reset acceleration always happens. We haven't started that yet. Update your location should only happen if you're alive. Right? No, because the zombies. This updates the zombies' locations too. But okay, so we have those. Update velocity. Unless I'm gonna have like the zombies be alive too. You know, I wonder, was that the problem? That I was like moving away from other humans? That was the problem. It was they were moving away from each other, which then made them still look like they were moving. Okay, now they're. Those two are still moving just slightly. The accelerations aren't being reset. Their velocities were set for some reason. I mean, it kind of does look like sometimes they're crawling away, so that kind of that works. I love the number of humans that still are dying to this because they're just wandering right into the zombie. It's kind of hilarious. But okay, I think this is working. So we're clearing that. Okay, so everything is good still here. Then what I would want is I want the let's see, what do we want to work on next for? Okay, so this is basically like humans are dying. So let's go ahead and pose and like commit this. I'm not gonna worry about that. Come on, I want everything other than this closed. Okay, so in our zombie simulator, we are zombies are biting humans and killing and causing them to start dying. And in BBECS, we are turning the index of the entities with each query. I'm thinking like before we actually do like the tutorial on this, we're gonna have to figure out either create like a macro for querying or like make that a lot nicer. I'll probably create a struct to hold these things differently instead of the tuple. But okay, so we have like the humans are hitting that. I want to now, after a certain number of seconds, ticks probably, I want the humans to actually be fully dead and like removed. So that's more, let's like update for dying. We're gonna have how long it takes them to die. So we have dying here. Let's have some data in here. This could be just like a U size. I think like U32 will work for this too. So let's impl. It's also in our struct. Sorry, in our config. So hub how like dying time. I want this to be U32. So in main, our dying time. So we're doing 60 frames per second. So let's say we want like 10 seconds that you're dying. For 10 seconds, 10 times 60, that would be 600. So 600. And then that means in the main library, for, oh, it's not that. It's now, no, it's not that. Should be an error. Oh, because we're not using dine, are we? Not yet. We just removed alive. So like how long you are dine. So we need to have a system to add a component in. I think that's the next problem. We have dine. You're there. Nobody has like dine. So in attack, we remove a component for this. We now need to add a component for this specific and for this entity. So I'm thinking this can be directly on world. It's like world add component. And then we'll probably have to give it the entity ID. Yeah, that's what we're gonna have to do. So let's head over to entity. Now we have add component here. Which gives everyone a none. We set the new bit mask. Okay, so we can add a component. I, however, want to sort of like give a component or like set a new component. Add component to entity. Okay, so let's say we would need our type ID. Which is going to be the reference to that type ID. Let's make this. We'll take in our T, which is going to be any plus static. So that is one less thing that has to come in here in the signature. We're going to need the component itself. Actually, I don't need this. I don't need that. We just need the component, which impulse any. And then we need the entity index, which is this usize. And then for this, we have to first check to see if this component is something that we've seen before. If it's not, then we need to do the add component up above. Okay, so that's gonna be the first thing we check is, so if let some, this is gonna be the components. So if let some components equals subject components get mute components type ID. Okay, I think that's correct. So if it's a none, we want to do the add. So here we'll do the else add component type ID, and then the component. No, it just take, oh no, it takes both. Yeah. Oh, this is not doing what I was thinking I was doing. This is adding. We have to rethink about this. Because I don't think I want to add a new component to this. Unless we switch back to the register system. I'm really thinking that the register system is going to make things a lot simpler for us. Because if I'm doing register at the beginning, I don't have to like check to see if it doesn't exist. Like what's actually happening? Like what are we doing here? If we can find, if we've seen this component in our system before, then I want to for the entity index of this, so we have this like vec of options for that. We want to go find the appropriate one, and we want to now set it to be the right thing. So it's going to be a sum with this component. So that's what this is going to be. We're going to say components of this entity index equals sum rc new refcell new component. I think that's correct. And then we also need to set the bitmap of this. So then that's going to be self dot bit mask. Is it bit mask? Yeah, bit mask is there. So bit mask of entity index, I think or equals is correct. Self dot bitmap to get component. I think that's correct. So that sets that now. So like, hey, you have this. Great. Okay. However, let's just do that here then. However, if this doesn't exist, what do we need to do? We need to add you to the bit mask. So that's going to be, we need to add you to the bit mask. We need like a do complete like row of nuns. And we in add component, like I would say this is very close. but it's doing one extra thing, I think. So we create an empty vector of components. We push none in for every single entity that we already have. Components push some RC new, ref cell new components. And then this is our problem. We're adding in to the very end because this is assuming a brand new component. I think what we want to do is break this out into two different things. Essentially want a register component so we're going to take this component and the type ID. I think that's correct. And I want to do everything except this component's push here. Let's see. So components push that. Self components, insert. So we insert you into that. That new bit mask. Okay, so we're creating the new bit mask and then we're inserting this into there. So, but like, you're gonna happen down here, and you're gonna happen down here. So we register component, add component is happening here. So then self, we would want to do a self register component first. Pass in the type ID and component, and we just do that. Then we're going to do add component. Add component is just going to add this component to the very end of our components list. So then to that end, we want to do let components equal self components get mute, that type ID. We should be able to unwrap you, I think, to then get at this and update you. Use to me value, register component. Can I just do a reference to you? Actually, I don't need the component in here. I don't need that. I just have the type ID. So hold on. I don't need you at all. Just the type ID. Okay, so then down here at the bottom, add component to entity. In or else, we're gonna just register a new component. So self.register component, the component.type ID. So we do that. And then we wanted to do this, don't we? Which, okay, so in that case, we want to do if a none for you. I mean, I kind of want to do this then. Oh, then we need to get you out. It's like, so this is pretty bad. Essentially, we register component and then I can do this all stuff. This is like completely duplicated here. So how can I combine these together to be one? So if the first thing we need to do is determine whether or not we have this type ID in there. So what if I do something like this? If self dot components dot, and actually maybe the bit mask will be bitmap dot, is there like a has key? Contains key. Component.type ID. And really what I want is, I want this to be false. So if you don't contain the key, then I want register the component. At that point, none of this needs to happen because now we're guaranteed to have you. And you need to be to reference. So if you don't contain this type ID key, then register the component, which then adds in the new component for everything. For both the bit mask and the components, and then go ahead and set this. So that's what I want to do. So I think, okay, this is now add component to entity and takes a component and an entity index. So we're going to go back to lib here. Add component to entity. Taking our component, which is an impl entity, and that, yes. Okay, so self.entity is add component. No, it's just going to be the component. Add component to entity, component entity index. There we go. Oh, it's just going to be here. Let's update you. That'll make you. That'll be a little bit nicer for ourselves. Okay, so this is going to add dyne to the human. Now dyne is going to be interesting because we need to put that into a resource to get that out then. Okay, so we've got our dying time now. So let's go ahead and add this into our main library here. It's gonna be a dying time. We're gonna do config.dying time. Okay, which means that, oh, keep on doing this. Accidentally adding in no public. Okay, then I need to, what would be next? We have dying time in here. So in attack, we need to now, we have this remove component. We need to get, get time equals world dot get resource dying time. Okay, that will give us this dying time here, and then here we're gonna add world dot add component to entity. Our component. So we're gonna be doing no, not dying. I guess it is dying. Is it dying? Yes, it is dying with like the amount in there. Okay. So yeah, dying. And then I have to give you be public. Dying, and then this is gonna be the amount of times. It's gonna be the dying time. We have to dereference you a couple times. And then our entity index. So that is this. Borrow world is mutable because it's also borrowed as immutable. Uh-oh. World remove component alive. Oh, because I'm in this like for loop here. I almost want, I wonder if I need to do like the update. So really we're gonna like schedule this to happen. Like we're going to remove component alive. We're going to add component entity, but give us time. Because otherwise we're in here, we're in this for loop. Now, can I? Is it the entity index part that's really upset about? No, because we do this world remove component alive. So mutable borrow, so immutable borrow is on line 18. Oh, where I'm getting the dine. Okay, hold on. I could just. Well, how about we just do that? Now dying time is exactly what we want it to be. Now I could do that. Now you're what you want. And everyone is happy. So I don't have to have access to it for that the get resource. Okay, good. Let's see. Add component to entity. Then what would be next? We've added dyn to the entity. So now I probably want another. I need a system to like update dyn and subtract 1 tick from it. Every tick. So let's add a system here. So update dyn. Not exactly. Close. Okay, so no. We want to query for everything that has dyn on it. So let query, it's going to be equal to world.query with component dyn and run. That's all we care about. Run that, and I don't even care about anything else. We're just going to get that. Okay. Okay, so we have our query. Oh, also missing another one. Yep, we need to return a result. All right, so we have our query here. I want to loop through all of the dyn entities, and we're going to update them. So I want to do that to get the first one. That's all we care about right here. So we're going to do for basically it's our dyn entity inquiry. Oh, so it's our for wrapped dyn inquiry. Don't want to. That's fine. Okay, so we have you. Then I want to borrow you. So borrow dyn equal, no. Well, so we're going to do the wrap dyn borrow. Okay. Then we're gonna downcast you. Oh, and you need to be mutable because we're gonna borrow mute. Okay, so now we're gonna have dine. It's gonna be equal to our borrow dine. We're gonna downcast mute as a dine. That gives us a mutable reference to dine here. And so then I want to decrement. So let's go to dine. Let's import a decrement. So let's try this. If I write a documentation for this, maybe Copilot will figure out what I want to do a little bit better. So we're gonna decrement the number of ticks that the entity has to live. Okay. No. Okay, you didn't figure that out. So we're gonna do pub function decrement. No, we're not gonna take that. We're gonna take mute self. Set to 0 minus equals 1. Okay, well, sure. Yeah, you figured that part out. Then an update dine. We're gonna say, no. Dine.decrement. Okay, so then let's run this. So in Zombie Simulator, update dine. We don't need mutable reference to the world. Okay, so this should work. However, it's like not really going to be useful to us unless after we're dead, we have to remove the dine. We have to delete the entity. We want to delete the entity. And that's gonna be really rough for us. Is it gonna be rough? We want to use the okay. So we don't have a delete yet. We need to add in a delete. Let's go ahead and commit this. What do we do here? We could add, okay, so we can add components, entities. We are entities can now start dying. Great. Next up is going to be actually killing the player. So, well, killing the player, killing the human. So we need to, when we reach 0 on dying, I want to delete the actual entity. Now, is that true? I don't know if I need to delete the entity or we're just going to convert them into a zombie. we're really gonna convert them into a zombie, aren't we? Unless we have like a chance that they're not going to turn into a zombie. Then we might delete them, we might convert them into a zombie. If we're gonna convert them into a zombie, what's the big thing that we need to do? We need to remove the human from them. And okay, so let's try that. That may be a little bit, that might make a little bit more sense. So this is turn into a zombie. No, it's not how these systems work. Obstruct that. Impult, turn into zombie. Function, run. Okay. Okay, so in turn into zombie, oh, and the world. Cannot forget the world. Okay, so in turn into zombie, we need to query for everything that is dying. And I think that makes sense. We're gonna query for everything that is dying. So dot query with component dying. Let's start here. And well, we are going to care about the index here. So let's do this. So in reality, what we really want to do is destructure this. So we have entity indexes and the query out of here. Now we can loop through all of the dying creatures. So for wrapped dying in, yeah, we could do create iter. Let's borrow dying. Dine that borrow. Oh, I really want this to be query of 0. That iter, and you're gonna be borrow like that. Okay, so we have a ref dine. If we're dead, so we might as well go into dine. And we can add like a function here. Is dead. Okay, yeah, this works. Yeah, sure. Because we're decrementing it. So if you're 0, you're dead. So we have that. Oh, we do need to downcast you. So that dine equals our borrowed dime dot downcast ref. And you're gonna be a dime. Okay, so if you are dying, if you're dead, we're gonna do stuff. If you're not dead, we don't need to do anything at all. So if not dying dot is dead, we want to just continue. If you are dead, what do we want to do? If you're dead, then we want to strip everything that made you a human away, and you're gone for good. Is that how we're gonna do it? Strip everything that made you awesome, wonderful. Let's go into the main library and take a look. What makes a human a human? For our humans, we have location, velocity, acceleration, speed, vision range. So your vision range needs to be updated to a zombie vision range. Your color needs to be updated to green, to the zombie color. You know, I wonder if I can get away with just adding a component. Actually, we can remove the component human, and then we can add a component zombie. I wonder if we can just do that. That I wonder, like, if I just add a component zombie. So this is gonna be world dot add component to entity. Our component is gonna be zombie, and the entity index is gonna be entity indexes of position. So we actually need you. Index there. So I do that. Okay, we do need mutable reference to this world then. Then you should start going and attacking others. To make sure that we can actually see this, we need a query for colors too. Okay, so with components color, so that's 0 for the dimes. Then we want to get your color out here. So let wild color. No. You're gonna be the query of position 1 of position index.borrow, okay? But we need you to be borrow mute. Then we're gonna have color is borrowed color, downcast, no. Close. Lumico. Let's see. You wish you continued studied Rust. It is fun. What are you studying? We're gonna do get downcast mute into a color. Unwrap. Reading Rust by example, Rust book. Well, can't you do like a project in Rust then? That would let you like keep on learning and improving in it. Okay, so now we have this mutable color, like reference to the color that we can then set it to be something else. So we're also gonna want to let like the zombie color. Let's not do this in the for loop. Let's do this out here. So zombie color is equal to the world dot get resource. Zombie. Wait, do I not have a resource for zombie color? Oh, is zombie color just green? Okay, we need to like update that. I think because like turn into a zombie. Oh, add zombie. You have the zombie color right here. We need to update this. We need to have a zombie color in the conf. So the config, we need a zombie color here. So graphics color here. That means in add zombie, we're gonna take this, go back to main, go back to the other main. Zombie color, you're gonna be that. Send back into the library here. Add in, okay, so we need a zombie color resource. No, we don't need that. So you're going to be a graphics color in there. We probably want something like a git clone. Okay, so we need to impl the deref. So impl deref for zombie color. Graphics color. You're going to be a reference to self.0. Then we're going to want probably like a git clone. Let's try this. So if I do impl of zombie color on a pub function git clone, which takes in a reference to self and no, it's going to return a brand new graphics color. Then this is, no, we don't need that. We could just do self dot 0 dot clone. Oh, it implements copy. So perfect. We can just do self dot 0. So you'll copy out. So in fact, this is more of get ggez color. That's what we'll name this. Okay, so in turn into zombie, we're gonna get this color. So we downcast mute to you. Can I then like do No? What do we call it? It's the get GG easy color. Oh, wait, no, wait. Wrong area. It's up here. Oh, we haven't done it yet. In here, so here we're gonna do that. Add the source. This is gonna be the zombie color. This is gonna be config zombie color. Now in here, we're gonna do let zombie color. It's gonna be equal into where was that? Resource. Zombie color. Unwrap you. And then we're gonna do a get GGZ color. Okay, so that gives us that color here. So then in this color, we can now set you here. So we can do color, set color, zombie color. It's just set, isn't it? There we go. Okay, so that should set you to be that green color. Perfect. What do? Also, don't get the resource here. Get it here. Zombie color. Unwrap. There. Okay, there's no errors. What's the chance that this is gonna work? None. Okay, so component for entity not found. Oh, because it doesn't exist yet. Doesn't exist. This is our big problem here. This is no, not there. Component not found. Now our last thing into is turn into a zombie. So we're attempting to get anything that is dying, but nothing has dying yet because, well, we're not dying. So we need to do this. Here's our query. We need to do this entire thing here. Where we match on you. Okay, so if you're okay, we get this query. Just gonna return the query, which is exactly what we expect it to be. If we get this error, we get the error. Now we're gonna return match on error dot downcast ref to errors. Okay. So the match arms. Okay, so if we have some, and then this is going to be the component not found. So if this is the errors component not found, then we want to return okay. Otherwise, if it's literally anything else, we want to return a new error with the error wrapped inside. That should allow us to handle this. So, let's see. Oh, did I do it somewhere else too? I think I did it somewhere else in one of the other. Not run away. Update dying here. Update dying here. Okay, so let query equals, we're gonna match on this. Okay. So, okay, we're gonna get query. Return the query. Now in this case, we only care about query.1 and the first one. So that should be fine there. Now, if we're this error, we're going to return match on the error.downcast ref. And you're going to be in errors. If your sum from the component not found, then we're going to return an okay. Otherwise, we're going to return error. All right, let's try this. Which does not implement the copy trait. Okay, so, a reference. Okay, let's try that. So you just want a reference here. Except I don't think I can do that. Can I just do in dot iter? Does that make you happier? No. So query.1 of 0, the first one. Let's actually just do this. Query gets this, and then here I want query dot one of 0, and then iterate through that. Yeah, that makes you happy. Okay, does this work now? Wow, the zombie is so bad today. Okay, it died. Let's see if 10 seconds later that turns into a zombie. No, it crashed. What happened? Attempted to subtract with overflow in dyn. Oh, okay, so we attempted to just decrement, but we should always make sure, okay, so if self dot 0 is greater than 0, then like let's like rename this to decrement if possible. You're gonna be decrement if possible. All right, let's try it again. feel like it's been more than 10 seconds. And something should have happened. Okay, so in update dyn, decrement if possible. If self.0 is greater than 0, self.0 minus equals to 1. So if I do a debug here, and we just say like self.0, so we should see like a bunch of countdowns start happening. Oh, do you ever reach 0? Oh, okay, here. This one reached 0. Okay, so this one actually did reach 0. Okay, so that makes sense. So it updated dieting. Okay, so then is dead if self.0 is equal to 0. So that would make sense there. So what's happening? Wait, did we? I feel like we may have not put in the turn into zombie. Did I just forget to run that? Yeah, we update dyn. Let's try that. So, that works really well. The new zombies are really fast. However, they're gonna murder everything really quickly because the zombie speed is different. Zombie speeds are different. So like in add zombie, we also have like this zombie speed and zombie vision range. So first of all, we need to update this. We need to like not have this anymore. So zombie color, zombie speed, and zombie vision range needs to be in the config. So we have zombie color, hub, zombie speed, and then vision range. There we go. So we have 0.01 for speed and 100 for vision range. Then okay, so speed was 0.01, and vision range is going to be 100. So double the humans. Now we need to add in speed and vision range as resources. You're gonna be an F32. Let's do a couple things here. So we can do like a get. So impl zombie speed hub function get takes in reference to self, return F32 self at 0, impl deref for zombie speed 32. There we go. And then in our main library, so add resource, this is gonna be zombie speed with the config.zombie speed. Okay, and then if we go into add zombie, now there's a couple of these. So zombie color and zombie speed are now in there. So we should be able to extract these out. So now I could just get them here. Like let zombie color is gonna be equal to this is gonna be world dot get resource zombie color and then dot unwrap and then dot get GG easy color. Okay, and then the other one is going to be let zombie speed world dot get resource zombie speed unwrap. I think it was just get. Yeah. Okay, so that gets us that. And then here, so zombie color is just color. Here's zombie speed. Okay. Finally, zombie vision range. Set new resource. Nope, wrong one. It's gonna be impl deref okay, got that. Then let's go ahead and create it. Okay, so add that in, and then add zombie. We're going to extract this out. Close. So you should be taking these ownership from them, so we shouldn't need them anymore. Oh, but this clicked location there, so we need this above here. There we go. Now we're fine. Then we're good here. Is there anything? I could swear I saw that there were some of these that were unsaved, but I guess we're fine. So now in turn into zombie. So when we create this, we need to update your vision range and we need to update your speed. So we need to get that out too. So we have our let's just get that up here. So we have our color. Where did we get that from? Oh, okay, so here's our zombie color. All right, so zombie color. Let's also grab out the zombie vision range. So let's do zombie vision range. So we're gonna do world. Got resource, zombie vision range. Unwrap. Pulled close. I think it's just get. And it's gonna be zombie speed. Okay. Now we need to get the others, like the speed. So when we query, we need to get your speed. So components, speed with components. Vision range. Then in here, okay, so we wrap dine, so we enumerate that, so we have your index. Okay, so we have the borrowed color equals this, and we set the color. Now we just want to do the exact same thing for our speed. So let borrowed speed query. Now is it 2? So it's 0, 1, 2. It's actually 1. So really close. And then index, borrow mute, yes. Speed, that's correct. And then we're gonna say speed dot set zombie speed. I would love that to be a case, but there is no set. So let's go into speed. I don't have a set. Let's create a set. There we go. Okay. So we set that, and then the final thing is the vision range. So vision range query. So you are query 0, 1, 2, 3. So you're 3. Okay, so I think this is gonna work. So now let's see if the zombies all act exactly the same as they were before. So after 10 seconds, that guy should come back. Oh, and then they died. Oh, already borrowed. So in turn into zombies here. So we're borrowing, this vision range right here. So we're going through, we need to drop these, don't we? I thought they would drop here. What exactly? Turn into zombie, line 54. Oh, yeah, look at this. Borrowed speed, borrowed color. Query one. Oh, that's wrong. So color and speed. We need to double check that. So 0, 1, 2. So speed is 2. Okay, let's try this again. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, around 10 seconds. But it's back. And now it's going to start murdering everything else along with those other zombies. I love how they're trying to hang out near the other bodies and are just eating the other bodies, essentially. So I think this is working out really well. And they're kind of swarming too, which is great. So the humans are being pretty stupid. They're just sort of randomly walking around. They're perfectly happy to randomly walk around as long as they're not getting too close to each other, but they don't really care about zombies, which is probably the wrong reaction. We're gonna want them to run away from the zombies. So that means if the humans see the zombie, they need to move in the opposite direction. let's go ahead and update all of this first. Resistance is futile. I know they're green. They could be Borg too. All right. So then we are dead humans resurrect as zombies. I don't think we had to change anything in here for that. No, we did not. All right. So humans running away from zombies. How is that going to work? For each human, we're going to have to find a zombie. Okay, for each human, we're going to loop through all the zombies. Okay, so finally going to work on this. Let's start by querying for all of our humans. So we're gonna have, I don't think we're gonna need indexes here, are we? So like it's gonna be that, human query equals world query with component human and alive. So if you're a human and you are alive, we care about you. Okay, so you're a human and you are alive. We also need your location. You're not human. Well then, Lumicode, you're safe. We need your location. We'll probably also need your velocity. I'll worry about that in a second. We need your vision range. So with component vision range. So we need humans that are alive. We need to know how far they can see, so that we can see if they can see the zombie that we're checking against. Okay, so then we're gonna loop through all of our humans, and we're definitely gonna need an acceleration because they're gonna run away. So with components acceleration. Okay, so that's 4 index. So this is gonna be the human index, and the human, we'll just do human location. We wrapped human location in, this is going to be human query dot iter dot enumerate. Okay, so then we have these things. Oh, and then human query of the 0, 1, 2. 2, second thing. 2. Okay, so that gives us that. Let's now extract out our location. So that this can be a borrowed human location. It's going to be equal to, yes, actually, that is correct. Okay, so that gives us refdine any. Let's bring that down and downcast it. So that human location is going to be equal to the borrowed human location dot. We're going to downcast ref. Okay, so we get this. Then we get our human location. I now want to take that human location and we're going to test it. Okay, so we're going to then check to see the length of it to other zombies. So now we need to query other zombies. So let we also have this. What was this? Zombie query? Yeah, actually, well, that's almost correct. That closing parentheses isn't correct. So world query. Yes, you're a human. Oh, sorry, that you're a zombie, and then we need your location. And I don't think I need anything else. Cookin', hello. All right, so import you. I mean, I've done teaching in the past. I'm not a teacher as a trade anymore. Let's see. So we have you. So, okay, so we have this human index, so we can now reach into those. All right, so time for us to get the distance here, which means we have our vision range. We're gonna say if human location dot distance with the other. So this is going to be a reference to the other vector. So it's going to be reference and a double dereference to this is going to be the zombie query. Oh, we can't do that. Hold on, hold our horses. We have to first get the zombie location. So let the borrowed zombie location. This is gonna be zombie query of 1, so 0, 1. Yes, that's true. Okay, you got that sort of. Oh, almost. Index. We missed the index there. Oh, wait a second. We need to loop. What am I doing? We need to loop through all the zombies. So for zombie index, wrap zombie location in zombie query 2, 1, 0, 1. Okay, so almost. For the index location zombie query 1 dot iter and enumerate. Okay. Then we're gonna borrow zombie location. Okay, so we do that. Then we're gonna downcast this. So zombie location, downcast raft, location. Okay, so we do that. Now we have our location. Now we can do this. So now we can do if human location dot distance, then the other is going to be this double dereferenced zombie location. Okay, so if that is less than human location dot distance, no, we're not going to do that. This is going to be our vision range. So we have to grab the vision range here too. So let borrowed human vision range. Zilby, what's up? Hello. Oh, also you can see the carpet. Hi. Are you here just to hang out? Let's fix this real quickly. This is too far. How about that? And this one too. There we go. The other day, Zilby, it was after the stream. Zilby like jumped up on here and he was just hanging out, and then he decided to jump on top of the on top of the green screen. I didn't notice until like the very last second, and it was too late. So he jumped up there. I think he thought it was like something he could stand on, but because he was coming at an angle, he just knocked the entire thing over and rode it all the way down, and that freaked him out. I'm glad he's still willing to come down here. Philby, I've got a treat for you. If you want to hang out with us. Philby. Okay, never mind. If he comes in, we'll give him a treat. Okay, so we're gonna get broad human vision range wrapped. So it's really close, but it's not figuring out like exactly what needs to happen here. So borrowed human vision range equals, okay, so this is gonna be the human query of position 0, 1, 2, 3. Of then human index, and then we're going to borrow. Okay. Then we borrow. Okay. Now we downcast that. So let human vision range, borrowed human downcast wrap vision range. Okay. So then it gets that. Then if human location distance, zombie location. Okay, so if this is going to be less than or equal to our human vision range dot, is there a get? I think we have a get. Yes. Okay, so if we can see you, if you're less than or equal to this, so if the human can see the zombie, now is the time that we need to like get an acceleration and skedaddle on out of here. So we need to take the human location minus the zombie location, and that gets us a vector, and we can normalize that, and then so we need a speed. We need our speed. So at this point, this is when we need to get the speed. So human can see the zombies. They can't now. They've been blissfully unaware that they're being murdered by the dozen so far. Okay, so let borrowed human speed. So human query 0, 1, 2, 3, 4 is 5. You're so close. Okay, and then with human index, and we borrow. There we go. Then human speed, we downcast that. Then, what have you been upset about? Your opening, I haven't opened there. Did I close early? Oh, I just needed to save. That's all. Okay, so we have our human speed. Okay, so now what we need to do is create a new force. I guess we can create the force now, or we can get our acceleration now. I don't know if it really matters that much. So we're gonna create a force. So that's gonna be so that our force, this needs to be mutable. This is like run away force is going to be equal to our location. So the human location, this is going to be human location minus the zombie location. Okay, so that gives us this vector 2. Then I want to, oh wait, what's going on? I want to normalize this runaway force, and then we want to I mean, this is actually correct. We want to do this, like that technically works, but I think Clippy is going to have a problem with it. Similar name, you say, huh? Human speed dot. What are you? You are. Just do that. I think I actually just have to do multiply assign human speed. I don't think I have a get on this. I think you're just gonna have to be dereferenced like that. Okay, so that gives us our runaway force should now be scaled up to the right amount. And now we need to apply this to the acceleration. So we have that here. Now we need to get that. So let mutes human acceleration equals, okay, so this is going to be human query of position 0, 1, 2, 3, 4. Oh, 4, you got it correct. for, so for human index, we borrow mute. We borrow mute. Then let human acceleration. Oh wait, this is gonna be borrowed. Then human acceleration is equal to borrowed human acceleration downcast mute. Okay, so now I have access to that. Now we want to take human acceleration dot plus equals the runaway force. We don't actually care about the zombie index. So you're all good now. So we're going to go into the library and we're going to go into the other library and run away from zombies. So let run away from zombies equals that. No, not that. Oh, come on. Where were you? Implement this. You saying you can find that? Oh, I guess. Wait a second. Did I already do this? I didn't. Just run away from zombies there. We do. Wait, we already did this. We were smart about it. Okay, so does that mean it's just gonna work? Are humans gonna run away from zombies now? No, it's just gonna crash. Component for entity not found. Entity not found because zombies don't exist yet. So we have to do this entire fun thing again. So here is gonna be a little bit easier. So we're gonna say that zombie query equals match you. Okay, so we're gonna do query and return query dot one. That's it. If it's an error, take this error, return a match on the error. I'm gonna downcast to errors. Okay, so if it's a sum component not found, return. Okay, we're gonna just early return. If it's anything else, we're gonna return an error. So now everybody should be avoiding these zombies like a plague. Now, humans have very small vision ranges, much smaller than zombies do. So the zombies should still be able to capture them. But you'll notice like no zombies are getting close to them if possible. But when a zombie starts moving fast enough, that's when that happens. Or if the players are moving fast enough, then, or humans are moving fast enough. Yeah, they're getting caught. If the humans get caught in a corner, they are dead. But yeah, I think it's working. Oh, look at that. Okay, so zombies are attracted to each other, which is not necessarily a bad thing. But I think when we get killed, So turn into a zombie. Let's also remove component human. So if I do this, I think the zombies are going to stop being attracted to each other because they don't see each other as humans anymore. Okay, I'm liking this a lot better. Now they're all attacking independently, separately from each other. They're only going to hang out together if there's humans right next to each other. It's definitely taking longer for them to kill humans now. Humans are actually surprisingly good enough to go like, do. Oh look, zombie, I'll just go the other direction right now, but continue on with my day. Until corner time. Now, I don't have any code that makes the zombies actually group together, but what's happening is in the zombie radius that they can see, in their vision radius, every human, they go a little bit towards every human. So they're like constantly going towards everybody. So if they're grouped together, just happen to be, then there's a chance they're going to move together also because like they can all see all the different humans. But when one of them eats a human, they stop. Like that one stops. And that's how they can get separated. Whereas the other ones don't lose their velocity. So these humans tend to survive a little bit longer than I was expecting to. Where's the White Walkers at? We humans are the White Walkers. I'm pretty sure that's what that means. Okay, the human. You know, I haven't watched more than one season of I don't even know if I finished the first season of Game of Thrones. I don't know, like I never really just got into it. So the zombies still seem to be attracted to each other. Am I not like? So in attack, we remove the component human from this. The White Walkers were the monsters. Were they like zombies or something, essentially? Let's see. Add component entity dying. I guess like what I might want to do is leave that there. And then we want to remove component human when you turn into a zombie. So when you turn into a zombie, we have this. Okay, so if you're not dying, then time for you to now be oh, that humans and our zombies, so they're eating each other essentially. Oh, there, that would be like terrible for the zombie. It's like I'm a zombie and I'm still being like eaten by other zombies. That's not good. So if I do world dot remove component, no, not that one. Remove. I guess it is remove component. No, wait, that doesn't make sense. What was I doing? It was, oh, it's this. It's not telling me it needs to do that. Remove component. This is gonna be human. And then you're gonna be the entity indexes of index. So I think at this point in time, they stop being human. To really make this like easy to see, let's go into our main library and let's say, no, our main. Let's say that we're gonna have 5 humans. I'm hoping to do that. Okay, so here's a zombie. Zombies don't move. They don't care if they don't see any humans. They're just standing there. Humans can't see the zombie until they get close. Now the zombie is moving towards there, but he lost the human. Let dying equals borrowing dying. I know. I love how like it ends up like looking like that, reading like that. Okay, so the zombie attempts to continue moving in that direction. But that kind of makes sense. It's just gonna slowly move across the screen, looking for our human. And the first human to just sort of like stupidly wander too close to it and get caught in a corner is gonna get killed. Like this guy. Oh no, he just juked away. The zombie's just too slow to catch them. Well, I can help out. What? Ah. Oh. You want zombies like in a world? You know, I never watched World War Z. I read the book though. I really like the book. I like the Max Brooks books. I think they're pretty fun. Okay, so here. There, got ya. So you staying there, you're eating that human. And as soon as that human turns into, I like that human walked up and was like, what's going on here? Oh, I am out of here. Goodbye. And so he should just Oh no, he's not gonna start wandering there. They're both at the same location. They're both right there. Because they have the exact same velocities, they have the exact same. And look at that. These two are now orbiting each other. So what's happening with my zombie attraction? Oh, human query is literally oh, look at this. Okay. I need to, this query is wrong. We need to update you. So we want to do with component. So go after everything that's alive. Go after everything that's alive. I think that's what our problem is. Yeah, they were being attracted to other people. I totally missed it. Okay, so let's go back to 100 because I think we're ready for that. And zombie comes in the middle and just starts going crazy and attacking everybody. And then immediately left. I kind of like the idea of the zombie. Okay, no, I don't like that. The zombie, I want you to be... Zombie attraction is not to just alive, but to human. You're to human. They die, but he's still eating. Because like that's like the classic movie thing is you approach and there's a dead human being eaten by a zombie until they resurrect and then the zombies don't care anymore. That's what we want to do here. So for like 10 seconds, they get a reprieve while the zombie just munches on this human. Oh, what's interesting is that, they don't really get a reprieve. The zombie sees somebody else. The zombie are still attracted to everybody else because they just killed. Oh, yeah, okay, that makes sense. So it actually does make sense that they leave. Because they eat that person, but then they're like, oh, hey, look, there's more humans that it can go after. And so like slowly go after them. Look at this. Okay, now the zombies are separated out and they're all moving separately from each other, which means they're going to kill a lot faster. Okay, I like this. This is looking good. This is now spreading appropriately. The scariest zombie movie you've seen is Ari Wreck. So fun fact, I can't like watch those scary movies. I get too scared and then I get nightmares. So I don't watch scary movies, but I apparently make zombie related things. So that's fun. The humans are moving much faster. Yeah, it is interesting. I want to like I must have something. Did I change this human speed? I didn't think I did. Oh, but you know what? When they run away, maybe something happens there. there's no cap on the human speed. That's what's happening on. There's no cap on the human speed. It's like every time they run away, it's like a little bit faster, a little bit faster, a little bit faster. And so then that can just go into really, really like much worse. So the zombies have almost completely taken over. Why is that? Those zombies are attracted. The zombies are attracted to each other still. There's something going on with that. Zombies are still attracted to each other. Am I here? Let's remove the live. Or wait. So you're human here. In attack, we remove alive. You're attracted to humans with locations, and then turn into zombie. We remove human. Or they combine and turn into giant zombies. That would be even worse. Then so you're going towards each of the zombies. I mean that should be fine. What if I just do both? Like with components live. So let's do let's go back to like we have one human here. Okay, let's do zero humans. Make sure that I've got this like actually working. Oh, actually, an entire thing relies upon humans existing, at least one of them. Oh, I bet this will crash. If there's no, I bet this crashes at the end when all the zombies are dead. So if I just have you, you're not attracted to each other in the least. But once you're dead, come on, die. They don't seem to be attracted to each other. So there was something else going on. There was something else causing them to be attracted to each other. Like here, okay. So I think we're good. Let's try this. We're gonna do 1250. I'm gonna turn, so set you to 1250. We're gonna turn off. Oh, for add zombie. We're going to not draw the vision range. Okay. And we have to do this one in release mode to get that many elements on the screen sort of like working together. All right, so here's all of our humans. Took a little bit of spin up time before everything was good. And now we, it's perhaps like too small of a location for humans. So let's take away their free will. Oh, that doesn't like that at all. As soon as I add one zombie, now it's terrible because like each zombie is like checking with every other one constantly, every single frame. But they're dying really fast. Okay, so 1250. Oh, but it's recovered. It's recovered as they just start dying like crazy. And they're all gone. All the humans are gone. Okay, so 1,025 is too many. Let's do 750. So this is the reason why if all of humanity gathers into a very small box, you should not go. Because humans are trying to remain away from each other, and humans are trying to remain away from the zombie. That's not working. They're hitting each other. But all right, I think I'm pretty happy with this. I love how it just slowly turns green as everyone dies. And then all the zombies will eventually probably find their way to the edges because they're just sort of wandering. Yeah, this was pretty amazing progress. I'm super happy with today. So, what does that mean for what we're gonna do? So let's. What was that? I had like a zombie. I had a warning somewhere. We can find that again. Add zombie. In add zombie line 51. What? Line 5. We don't need you. Okay, I think that was it. How can the human run into the zombie? So the way it works is we take the human's location, we take the zombie's location. If the human can see the zombie, the human moves away at their speed, which is like 1.5 times the zombie's speed. But when I mean move away, what I mean by that is the human, if the human's like moving this direction, the human starts applying a acceleration in that direction. Like let's say the zombie's up here. That's sort of like if you're running and then you want to suddenly turn around and go the exact opposite direction, you have to slow down, stop yourself, and then you can turn around and then you can run. So what can happen is if you're running too fast in one direction, you actually can't stop yourself in time before you just run into the zombie and then just turn into mincemeat. So that's what's happening there, is that the humans are moving too fast and therefore can't stop themselves. Okay, so now I could like limit their speed, but then I think what would end up happening is that a human with a limited speed could actually survive forever. because then they would just always be able to like stay away from the zombies, unless they got trapped in a corner, which I don't think is nearly as fun. Now, the idea for this is we're building a we want to build a tutorial for how to do ECS, like how to build your own ECS, and specifically for the purpose of like growing your Rust skills. So let's see. This is going to be zombies are I guess like humans try to run away from zombies. Yeah, humans have really terrible vision here. If we take a look at main, human sight vision range is 50, so 50 pixels, and that's a radius, whereas zombies is 100. So zombies can like see everything. Now, what I could do is we can like play with this, right? We can like try to make this like, you know, zombies can see everything everywhere, and like humans can't see very much, and all that fun stuff. Okay, so anyways, the tutorial is really going to be focused on the ECS. So my thought we're gonna have the zombie project is sitting here, and we're going to build, like, the tutorial is going to be build the ECS that supports this project, and then you can like read through this project to see how the ECS is going to be used, and then like afterwards maybe we can say like, well, what are like nice things we can do, you know, macros for like the query might be something we can do, but for the most part our tutorial is actually going to be in the BBS ECS world. We're going to be building out essentially this stuff. Now it's all built here, so we're gonna have to figure out what exactly we want to do and like how I want to build that. So that's starting tomorrow, I think is when I'm gonna start like actually proper planning for this tutorial series, and like what each video is gonna be on, and then probably starting to record those. Is it possible to introduce something like sound awareness for zombies? Yeah, absolutely. It's always possible to like do that kind of stuff, especially in a system like this. Like we could do something like humans make sound if they hit like a wall. Like if they hit a wall, then like a sound radiates and like a zombie goes towards that. Or like every time a human moves or something like that. Absolutely, like those things are definitely possible. I think it'll be outside the scope of like what I'm going to be doing, but like you could put a sound source into ECS, right? You could have a sound source could be an entity that just sits there. It has a location, but it doesn't have a velocity and a acceleration, and maybe it has like a radius and it has like a volume, and then you can have your zombies listening for those, and if it hears it, then that could like also be part of attractiveness. Like you can have like an attract towards noise system, but generally like the idea of ECS is that your entities don't actually know exactly what they are, but they're made up of components, and the combination of components makes up what you would consider like a human. A human is all these components. A zombie is all these components, and the ECS system doesn't care at all. It's just like, whatever, just hand me everything and I'll deal with it. So yeah, tomorrow we're gonna start planning that. But right now it's about 12, and I feel like I've been sitting here for a super long time. See, it's all 4.5 hours. So I need to go take like a walk around the block a few times to like stretch out. Let's see. You haven't been watching your whole streams. Usually you're working that time. You also find it harder and harder to find spare time. I totally understand. Like I find it hard to like watch other people's streams. I usually end up watching the VODs while I'm just doing little stuff. which means I'm not usually paying that much attention to it myself. So like, it's yeah, adult life. We should like figure something out about that. All right, so with that, let's go ahead and start